for allowing us to make this happen. With that, we are going to bring our next speaker to the stage. Our next speaker joins us, Jim. He is going to talk about the platform superpowers with policy as code. So let's bring
do we have Jim on? Jim is a longtime community member in the SF Bay. We go way back, running meetups back into your microservices days, and way back in the day of the early Kubernetes community that Jim has been a part of and helped us build in the Bay Area. So really appreciate all you do for the community, all you do for open source, and thanks for joining KubeCrash.
All right,
Thank you for having me. Yeah, pleasure to be here. Thanks, Lisa. Thanks, Danielle.
Great. Well, with that, we'll duck out and we will leave it to you to take it away.
Awesome. Yeah, so today I want to talk about what policy as code can do for your platform engineering strategy. So first off, let's start by trying to create a mental model for what a platform is, right? And we all hear about platform as product, which is great. That's a good first step. But what exactly is a platform, right? And what do we need to put as components in the platform itself? So first off, we know that platforms are meant to provide self-service to developers. So that's a key deliverable that you want as part of your platform strategy. But we also know that platforms are all about automation, right? And when you think about automation, you typically think about infrastructure as code. So tools like OpenTofu or Terraform, and then, also like GitOps. So like whichever tool you're using for that. But the other missing component here, which really completes the platform strategy and in fact gives it superpowers, which I'll show, is policy as code. And that's what we're going to talk about today. So what exactly is policy, right? So in our day-to-day lives, we all deal with all forms of governance and policy. We all, work in different environments, organizations. We know about things like vacation policies and expense policies and other things. But translating that to a digital and Kubernetes and cloud native world, what exactly is a policy? So policy is nothing more than a contract between developers, operators, and security teams. Now, ideally, the policy is something that everybody can read, everybody can understand, and everybody knows that it's in place and it's going to do its task without getting in the way, right? Because the idea here is not to be obtrusive to any one team or role, but to be able to empower everybody to do their jobs without stepping on each other. So policies really in the Kubernetes world become Kubernetes configuration objects that in fact are managing other configuration objects or behaviors, which is, and that kind of meta concept is really incredible and very powerful, as you'll see. But then, what about the as code part, right? Because we like to do everything as code, of course. We want to automate everything, including, all of the components of the platform. So when you're applying policy as code, it's not about writing policies in a programming language like Java or Python or Golang or any of these, but it's about managing policy artifacts just like you would software. So it's about developing policies, testing policies, distributing them, enforcing them at the right enforcement points, collecting all of the data, about the enforcement, as well as metrics for your policy, components, and then being able to manage things like reporting, exceptions, remediation, all of that at scale. Right. So it's really completing that whole cycle, again, empowering all three roles we talked about, developers, operators, as well as your platform team themselves. All right, so let's get to some of the fun stuff about what can policy as code do for your platform engineering strategy. And I'm going to talk about 3 superpowers that policy as code can provide for your teams and for you. So the first is invulnerability, the next is X-ray vision, and the last is super speed. So let's go through each one at a time. So we've all heard about, security teams talk about vulnerability management. There's a lot of talk about CVEs, vulnerability. But what if you could build a platform and a system that's invulnerable? Isn't that better? Why manage vulnerabilities when you can prevent harm from occurring in the first place? So really, policy as code flips that paradigm around. And if you look at any study, whether it's like any of the open source studies, other things, even from Gartner, almost 99% of issues in production come from misconfigurations. So why not prevent harm in the first place? And the way to do that with policy as code is by implementing some basic best practices, standards, organizational rules. Here on the right, what I've shown is a Kyverno policy. Kyverno is an open source project created and maintained by Nirmata within the CNCF, along with several other organizations and contributors. So this is the Kyverno policy, which prevents unauthorized images from running in your cluster. Now, if you look at this policy, you can see obviously there's some coding logic here. This is using common expression language, which is a language adopted widely by Kubernetes. So here, what we're doing is every time a pod gets created on line 16, it's matching pods. What it's doing is it's looking up a set of allowed registries, which you can control. And then it's checking if the images for that pod and everything in the pod, init containers, ephemeral containers, as well as regular containers are coming from that authorized registry. Now, that's just one example of a policy on the Kyverno website, or if you go to the Nirmata websites and Git repos, we have hundreds of other examples that we work with several platform teams, and we're constantly developing, managing, and it's not just Kubernetes, but it's also whether you're running service mesh or you're running AI ML workloads or things like Kubeflow. Each one of these comes with its own policy sets, which makes this really powerful. But just by doing some of these basic best practices, you've prevented harm already. You need to start with things like pod security standards, RBAC best practices, other basics like making sure every pod has proper limits, quotas, things like that configured, and that gets you a lot of benefits right off the bat. The next is, so now that we have prevented harm, how do we really see what's going on and get supervision into our clusters, into our cloud native environments? So let's talk about what policy can do there. And this is not just about enforcing policies, it's about managing that visibility. So Kyverno and policy engines like Kyverno, they can enforce policies, whether it's in clusters, pipelines, in your application layers, wherever you wish. But policies, once they're enforced, they create reports. And the API format for reporting, in fact, this is a little bit of a teaser and a preview. Next week, we're going to announce a new project called Open Reports. And that project is going to have a standardized reporting format for Kubernetes and beyond, which creates, just like OpenTelemetry does for metrics, Open Reports does for reporting. And once you have that standard, you get insane visibility into not just your clusters, your repositories, your other components where you're running, these policy enforcement and scanning tools. But now you can have other tools like Nirmata and others layer on top of that and really provide, visibility, reporting, collaboration across your clusters and your streams. So let's take a look at how this works in reality, right? So I'm going to actually just dive into a terminal and we'll take a look at it here. So we'll come back to this one. Let me clear. So here I have a simple cluster. If I look at my namespaces, I have Kyverno running in there. But for this purpose, what I'm going to do is I'm going to actually use the command line tool. This is the Nirmata command line, which layers on top of Kyverno. And then it's scanning your Kubernetes cluster. It's going to create a report in that open reports format, and then publish it into a central hub, which is where we can get full visibility, full controls on that report. So what's happening behind the scenes here is it actually contacted where you've configured your policy sets. Now, these could be Git repos, or these could be anywhere on your clusters. And once that's done, it went ahead and scanned all of your resources without installing anything. So super powerful. It also gives you this nice analysis. So it's telling me that, hey, my Nginx namespace, I'm just running, vanilla Nginx here. It has a bunch of misconfigurations, which is the most severe thing in my, tiny cluster here. And then once that's done, it's going to publish this report, which I can go share with the team. I can kind of, use, I can analyze, understand what's happening, and whether I request exceptions or actually, fix that, and I'll show how remediation works, that can be done, right? So policy as code now, what we just saw, it's enabling these type of, again, that level of collaboration across your teams, across developers, security, operations, all in a standardized language, all through open technologies. The last superpower I want to talk about is moving fast, right? We all want to move fast. We want to deliver value for our business, but we want to move fast without breaking things. So how do we do that, and what does policy as code, and allow us to get there? So I want to mention three things. First is early detection, and we've all heard, that detection is better than prevention. So how do you detect things early? And there, the more you do in your CI pipelines, the better, right? So if you can apply policies there with Kyverno and other tools, you can get, feedback directly to developers, and I'll show an example of that. Super powerful, right? And in fact, the screenshot shows on the right how you can run, the same CLI that I looked at, which builds on Kyverno, to be able to run scans not just on, Kubernetes manifest, but Terraform, even Docker files, or any JSON payload. The next step is self-service, so allowing and empowering your teams to do self-service remediation, self-service exception management, super powerful, right? And then finally, automation, and we'll talk a little bit about that. But let's take a look at what this means if, again, I'm in a team setting and I want this, to actually go ahead and, remediate an issue that we just saw. So all I'm going to do is I'm going to call a command called remediation, which is now going to take that because the policy is structured. In fact, underneath the scenes, we're passing that policy and the violations to an LLM, which we have tuned and trained to be able to be accurate in terms of creating patches on top. And this makes it super easy for, again, developers, just in a few clicks, without having to understand all the nitty-gritty details of what's going on, to get that feedback and to get the data for what exactly that remediation should be for that. Now, of course, if they don't want to remediate, or for some reason you cannot, they could go ahead and request an exception. But notice over here now it came back and just told me that, hey, this is what's the issue with here's a patch. It's recommending creating probes, which is a good best practice, again, based on the policies configured, right? So it's another simple way of being able to get developers to move fast, again, without making mistakes, without breaking things, and learn about what the best practices for Kubernetes and other things are. The final thing I want to talk about is automation. And typically, when we hear about policy, and a lot of times platform engineers will say, hey, policy is for security. Why do I need to deal with that? Policy is not just for security. It's about automating configurations at scale. And if you, like if you look at domains like whether it's telecom or networking or other, real mission critical infrastructure, which is 24/7 lights out management, they use policies for complete configuration management. And really, if you actually go look up the definition of policy in Kubernetes, it says policies are configuration for managing other configurations. So you can do some amazing things with policies, and think about a policy as just another declarative controller. Much like Kubernetes has controllers which manage other configurations, you can do things like cleaning up stuff in your cluster automatically, like failed jobs, like whether it's CRDs, things like that. We all know clusters accumulate a lot of garbage over time. By generating defaults like network policies, secrets, even fine-grained permissions, and finally, even mutation. So there are very good use cases for why you want to mutate things in cluster. There are, of course, you want to use GitOps as your source of truth for your basic configurations, but things like in-place resource updates, right? There's a great blog post from Adidas how they saved about 50% costs on their dev desk cluster by using Kyverno, integrating it with VPA, inheriting labels automatically on pods and fine-grained objects, injecting things like carpenter do not evict nodes, like all of these little things which are extremely painful to do. You can automate all of this, even node selectors, right? Salesforce has a great blog how they use Kyverno to inject node selectors. So some pretty incredible things. All right, so just to quickly recap and summarize, Platform engineering is all about providing self-service at scale. And to do that, you need automation. So automation is about IAC, but also PAC. So just think about it from that simple mental model. Combining infrastructure as code and policy as code gets you to these superpowers. The three that we talked about today, and there's more, but just had time for three. Prevent harm in your systems. So start with that. Forget about managing vulnerabilities. Make your systems invulnerable to begin with. See everything that's going on, and you can do that through open reporting and other standards. And be able to move fast and empower your developers to move fast. Right. And once you have this foundation, there's some amazing things you can do with systems like Nirmata and other tools which can layer on top of these technologies to be able to enable your developers and your internal teams. So that's all I had, but thank you very much, and happy to help hang out and answer any questions.
That's really great, Jim. Thank you so much. I hope that I put the correct link to the open reports.